I'm just getting your pretty hair in there. All right. So up here on the board, you see 3 different polynomials. We'll just work with the first one to start. What they're giving you here is they're giving you a polynomial. As a quick review, what's the degree of that polynomial? Cubic, or 3, right? What would the end of behavior be? Yep. As x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y is going to negative infinity. Okay, good. It says to rewrite each polynomial as a product of linear factors. Linear means a degree of what? 1. Yep, linear means a degree of 1. So what we want to do is we want to take this polynomial here and write it as a product of linear factors. Because this is a degree of 3, I'm going to need 3 linear factors that would multiply together to give us this original polynomial. Okay? Now, they helped us out a little bit. They gave us 1 of the linear factors. They gave us 1. But we got to find the other 2. How do you think we need to do that? Divide. Yep. Think about this. If I told you to give me all the factors of 945, go. Okay? You can't do all of them, but everybody knew 5 right away, right? Because it ended in a 5?
9.
So if you wanted to find all the factors of 945, you might start by dividing by 5 to see what that equals, right? Because if you know 5 is a factor, and you got to find the other factors, you might divide by 5 and then use that number to find some more. Okay? So if you know one factor, divide by that factor, see what you get, and then see if you can't find the rest of the factors. That's kind of in general what's going to happen here. Okay? So we're going to take this polynomial, we're going to divide it by x minus 7, see what we get, and based on what we get, I bet we can find the other factors. Everybody follow the thought process there?
Oh, wait, what's going on? What in the heck?
What happened?
It's a ghost.
Mr. Hanson messing with me?
Oh no, that's not really what Mr. Hanson does.
Alright, so again, one more time. Here's our cubic polynomial. Our goal is to write it in 3 linear factors. We know one of the factors, so let's do some division, and then with that answer, we should be able to find the other 2 linear factors. I'm going to use synthetic division. Okay, it's just faster. If I use synthetic division and I'm dividing by x minus 7, what number goes in the box? Positive 7. Okay, I'm using synthetic division. You can use long division if you prefer. All right? My coefficients are 1, negative 7, negative 16, 112. Drop the 1, multiply, add. Multiply, add, multiply, add. So that would be x squared plus 0x minus 16, or just x squared minus 16. Awesome. This will be a piece of cake, right? So a of x equals x minus 7 times x squared minus 16. I'm gonna mix in this extra step here, okay? All right? Because when I took this polynomial and I divided it by x minus 7, I got x squared minus 16. So that tells me that if I take x minus 7 times x squared minus 16, it equals that original polynomial. But you all know how to finish the rest of it. X squared minus 16 can be factored further because this is the difference of 2 perfect squares. Yep. So I got x minus 7, x plus 4, x minus 4. So we would be done with number 1 now. Okay? By the way, where does the graph of a of x, where does the graph cross the x-axis? 7, -4, +4. Okay, so you could draw a pretty good sketch of this graph now too. Okay? FYI, these little diagrams over here, you might see some of them in your practice. It's another way to do division. I don't care if you know how to do it. I'm happy to teach it at some point, but I'm not going to do it right now. It's just kind of a diagram division or like a lattice division type thing going on. If you can do synthetic or long division, I think that's good enough. Okay? All right, so what are your thoughts here? Number 1. Okay, now we're doing a fraction. Sorry.
Oh.
Okay? Just sat there, Amy. That's fine. All right, let's try number 2. B of x equals, it's another cubic polynomial, and they give us one of the factors, x minus 3/2. So I'm going to put 3/2, a positive 3/2 in the box, 2, -1, -27, and 36. Drop to 2. 2 times 3/2 would be 3 because the 2's would cancel out. Add them together. 2. 2 times 3/2 would be 3. Add them together would be -24. -24 times 3/2 would be -36. You better get 0 at the end because they told you it's a factor. And if something is a factor, the remainder will always be 0. If you don't get 0 at the end, you probably screwed up in your division somewhere. Because if they tell you something is a factor, that means it has to go into it evenly, meaning there is no remainder. Okay? All right, so that would leave you with a 2x squared plus a 2x minus a 24. So one of my factors was x minus 3/2. When I divided by x minus 3/2, I got 2x squared plus 2x minus 24. Now I'm going to do myself a favor here. I notice that this factor, every term is divisible by 2, so I'm going to bring a 2 out as the greatest common factor. I'm actually going to bring it all the way out to the front. If I bring a 2 out of that trinomial, if I factor a 2 out of that trinomial, what would remain in that trinomial? Good. X squared plus 1x minus 12. I divided a 2 from each term and brought it out to the very, very front. Okay? So then I got my 2. I got my x minus 3/2. What would this factor to?
X plus 4x minus 3.
X plus 4, x minus 3. It's got to add to 1, multiply to -12. So x plus 4, x minus 3. Okay? Any questions on what I did there? If you don't like seeing that fraction there, I would be okay. I'm going to put this 2 back into this first factor, 2x minus 3. This is not required at all, but that would be an okay answer as well. If you don't like the look of the fraction, this would be a way to clean it up and get rid of the fraction. It's still a linear factor. That's a linear factor because the degree is 1. Okay? Any questions? All right, I'm going to have you guys try number 3 there. Try number 3.